Hello children, how are you today? It's me, Kavya, your physics teacher. In the last session, we started with the first chapter, that is motion, and we studied few things. Hope you all have gone through that video. We studied about the objects which are in the state of rest and which are in the state of motion and few examples. When do you say the object or any body is in motion? We say it is in motion when the object changes its position with respect to time. Then we say that the body is in the state of motion. Few examples we discussed where the motion of the object or the body is taking place, but you cannot sense or feel it. For example, maybe the motion of the earth, and a few other cases where one object is in the state of rest. One person may feel that the object is in the state of rest, but the other person may feel the same object is in the state of motion. What was the example we discussed? A person standing on the platform of the railway station and the other person sitting inside the train. For the person standing on the platform, the train appears to be in the train as well as the passenger appears to be in the state of motion. But for the person sitting in the train, the person standing on the platform seems to be moving in the backward direction and he feels that he is in the state of rest. This was the example which we studied. And we studied that the motion may be in the straight path, or it may be rotation, or it may be vibration. But in few cases, it will be combination of all this. But we said that we learned that in this particular chapter, we will be studying about only the motion of the objects along a straight path. We have constrained our study to the motion of the body along the straight path. In today's class, let us study about the uniform and non-uniform motion. On the screen, you can see the definition of uniform motion. If the object covers equal distances at equal intervals of time, then it is called uniform motion. There is one condition, that is the time interval should be small. If at all the object is covering equal distances at equal interval of time, then the body is said to possess the uniform motion. To understand this in better way, as usual, let us go with the example. On the screen, you can see the graph. You all know origin x-axis and y-axis. The point where the x-axis and y-axis meet is called the origin. On the x-axis, you have the time plotted and the scale here is 1 minute. 1 centimeter or 1 unit is 1 minute. Like that they have chosen. So 1, 2, 3, 4, 5, 6 up to 6 minutes you can see. Similarly, on the y-axis, you have the distance which is represented in terms of meter. Again, it is in the equal interval of 10 minutes. You can see, 10 meters. 0, 10, 20, 30, 40, 50, 60. 6 minutes, 60 meters. Correct? Now, observe the graph. Start from 1 minute on the x-axis. If you go straight and touch the blue line and you have the point there which is exactly meeting at the 10 meter on the y-axis. Similarly, it means that in 1 minute, the body has covered a distance of 10 meter. Similarly, second minute on x-axis, now go straight and it has covered now the distance of 20 meter. Similarly, in third minute, 30 meter, fourth minute, 40 meter, fifth minute, 50 meter distance and sixth minute, 60 meter distance. Means for every minute, the body is covering distance which is equal to 10 meter. See, now to understand this, look at the y-axis now. You have the difference 10 in between those values. 60 minus 50 is 10, 50 minus 40, 10, 40 minus 30, 10, 30 minus 20, 10, 20 minus 10 is also 10, and 10 minus 0 is 10 again. Means the difference here is 10, and similarly, if you come to the time, that is on x-axis, here also the time difference is 1 minute. 6 minus 5, 1, 5 minus 4, 1, 4 minus 3, 1, 3 minus 2, 1, and 2 minus 1 is also 1. For every minute, the body is covering distance which is equal to 10 meter. Here, we say, now you understand the statement that equal distance at equal interval of time means equal distance means 10 meter. At equal interval means at 1 minute. 1 minute, 10 meters. So, like this, if at all the body covers equal distances at equal interval of time, then it is said to possess this uniform motion. Then, what is non-uniform motion? See the definition, and please note down all these definitions in your classworks as well. Definition of non-uniform motion. It is just the opposite of uniform motion. We studied in uniform motion that the object has to cover equal distances at equal interval of time. If at all the body covers unequal distances at unequal interval of time, then it is said called the non-uniform motion. Is just the opposite. For non-uniform motion, I hope it is clear to you which is not uniform, which is not going or following any particular time interval or particular distance at equal intervals. Then such motions are called non-uniform motion. Still, you can see the example there. When a car is moving on a crowded street, the driver cannot drive with same speed at intervals. So you all are very much used to the traffic. Yes, no. So when you are in a highway, yes, you can maintain the speed. But when you are on a crowded street or when you are traveling in the traffic, you cannot maintain the speed at regular intervals. Yes, no, you need to keep on applying brake, increase the speed sometimes, decrease the speed sometimes. So you are not able to cover these equal distances and equal intervals. Such motions are called the non-uniform motions. So after studying the definitions of this uniform and non-uniform motion, let us go through some more examples. So on the screen you can see the picture of a TV in which the cricket show is being telecasted, and you can see on the screen bowling speed in kilometer per hour. That is 140, 143, 135, 145, 132, 130, etc. As soon as the bowler bowls the ball towards the batsman, with what speed the ball is moving can be now calculated. So, how? In what unit means in terms of kilometer per hour. Yes, so in the next example, you can see a truck moving on the road. And on the road, there is a signboard. They have written on the signboard speed limit for car, and you can see the picture of car is the speed limit is 50 kilometer per hour, and that for the truck is 40 kilometer per hour. What do you understand by this? Why can't the truck go in the speed of car, or why can't the car go in the speed limit of truck? Think of it. So by these two examples, we can understand few things that are stated in the form of points there on the slide. You can just go through it. Different objects may take different time to cover a given distance. Best example for the car and truck example. Different objects may take different time to cover a given distance. Some move. Second point is some move fast and some move slow. Yes, no? The bicycle and a car cannot go with the same speed. Third point is the rate at which the objects move are different. Means each object has its own energy, so it can move with its own speed. Fourth point is different objects can move at same rate or same speed. There may be two different objects which are capable of they are moving in the same speed or at the same rate. So when we want to tell or explain with what speed any object is moving, we need its magnitude. We need the magnitude. Yes, no, like means the numbers. It is moving with the speed of 2 kilometer per hour, 10 kilometer per hour, 7 kilometer per hour. These numbers 1, 2, 7, what we mentioned now are the magnitude. So to specify the speed of any object, what we require is the magnitude. In most of the cases, the objects will be moving with non-uniform motion, will be moving in non-uniform motion. Hence, to describe the rate of motion of such objects in terms of their average speed. Hence, we use the term average speed in order to describe the motion of the objects which are in non-uniform motion. And the SI unit of speed is meter per second. You all have studied it. So, we describe the rate of motion of objects which are in non-uniform motion by using average speed. You know how to take the average of any two given values. Similarly, here you are calculating the average of the speed. It is given by the formula average speed is equal to total distance travelled by total time taken. It is the total distance travelled by total time taken. You have the numericals to be solved on this formula, so make a note of it. You will be studying it in solving the problems in further classes. Next we shall study about speed with directions. The rate of motion of objects will be completely understood, or you can tell it completely when we specify the direction of motion along with the speed. When you specify it with the direction of motion along with the speed. So the quantity that specifies both these aspects is called the velocity. So velocity is the term that can specify both the direction of motion as well as the speed of any moving objects. Hence, we shall study about the velocity now. You all have studied it in the lower classes. Velocity, it is the speed of an object moving in a definite direction. Or rate of change of speed of any body is also called velocity. Either way you can define it. So, velocity of an object can be changed by changing its speed. So, when velocity is changing with respect to time, you have studied that it is acceleration. Clear? Acceleration is rate of change of velocity. Here, the velocity of the object can be changed. How it can be changed? It can be changed by changing its speed and direction of motion, or both the speed and direction of motion. When the object is moving along a straight line at a variable speed, we can express it in terms of average velocity. Just now we discussed about the average speed. What was it? Total distance travelled by the total time taken. Similarly, to find out what is average velocity of the body, we shall use the formula initial velocity plus the final velocity divided by 2. In other words, we are taking the average of both the initial velocity and final velocity. You have studied the equations of motion, right? So, in terms of that, if at all you represent this average velocity, initial velocity is represented by letter U and final velocity is represented by the letter V. U plus V divided by 2 is the formula. For your reference, here again I have mentioned that U is the initial velocity and V is the final velocity. So, initial velocity and final velocity. For those who have not understood what are these initial and final velocity, let us consider the example that you all are riding the car. So, as soon as you start the car, you directly don't travel with high speed, right? You first slowly start and then gradually increase the speed. So, with what speed you initially started the car to move to move is called the initial velocity. And later when you accelerate it, it starts moving with great speed, with high speed. So, as speed goes on, increases. So that is the final velocity. Initial velocity, final velocity. The average of those two, that is divided by 2, gives you what is average velocity. So in today's class, we studied what are uniform and non-uniform motions and their examples. And we also discussed about the speed along with the direction. Speed along with direction, what it gives you together, the quantity which defines both speed and direction is velocity. And we also studied what are average speed and what is average velocity along with its formula. I want you all to read the textbook once. Any doubts, you can ask me. In the next class, we shall just recall this once and start with the numericals based on these two formulas which we studied today. Till then, take care. Have a nice day. Thank you.